College student, a very interesting question. In fact, I really like this question because it's highly conceptual. Okay, it revolves around the concept of center of mass. Okay, now I have drawn three situations. You can read the size of the font is very small, but I will explain you what is going on, and then we will discuss the question. So you can see three systems, right? One, two, three. Okay. These are three systems. Each one of them have same masses with the condition that M1 is greater than M2 is greater than M3. This is given to you, right? Now, the if you pick up system number one, an external force is applied on M1. If you pick up system number two, an external force is applied on M2. If you pick up system number three, an external force is applied on M3. Okay. What is also given is that the center of mass, okay, the center of mass A is given. Okay. So in all the three scenarios, let's read it actually, right? So let's see what it says. The same force S is applied to on the each system separately to just one of the, and it is given that the center of mass is A, right? So you can see the position of center of mass. Okay, so the in the down below, the center of mass is close to, it is close to M2. There you can see it is close to M2. So the position of center of mass is given to you in all the scenarios. What is the question? Which of the following statement is true? So let's think. The magnitude of acceleration of center of mass of the system is largest in figure 1. So if you notice figure 1, the force is getting applied on M1, which is the largest mass. Okay. I don't know why the force will be, sorry, the acceleration of the center of mass will be highest in 1. If you see the second choice, it says the acceleration of the system 2 will be highest. And third choice is the acceleration of system third will be highest. Okay. But if I, and the fourth choice is that the acceleration of all the systems is identical. Now, before we jump to the answer, let's discuss this conceptually. If you notice the acceleration of center of mass, how do you write it, right? So ACM is actually written as sigma m1 and the derivative of the velocity divided by sigma m1. This is first. Okay, sorry, I just removed the question so that you can see it. Okay, so this is what I've written. Okay, the acceleration of center of mass is recognized by this. Okay, so you write the position, then you take derivative of it, you get the VCM, and then you take the derivative of VCM, you get ACM. What is, so where does the concept come from, right? The concept is, remember the force is external. The force is external. That is a very, very important point to note. So what do we do when the force is external? When you talk about a system like this, contained by containing masses, okay? One system, second, and the masses are identical, but they're kept in a different configuration. But they are part of the system. The rule is that the center of mass is calculated by this concept. If you apply the concept on this particular situation, what you get to know is that on a system which is made up of many masses, if there is one external force and all the masses are identical, they are different three systems, the external force is also identical. Then the acceleration will also be identical. Right? Don't don't get carried away by the fact that you will apply center of acceleration of this will be obviously equal to F upon m1. But this is not the way to calculate when you're talking about a system of masses being acted by an external force. The force is actually acting on system. It's an external force. Whether it acts on this mass, or this mass, it doesn't matter. It is one external force and a system facing the force. So all these are actually the force. If I have to write it very simply, very simplistically, this is the acceleration each of the system having. Okay, this is the acceleration which I've written like that. Because if you see RCM, right, position is given by MIRI sigma, right? So I is equal to 1 to n, depending on how many masses are there. That's sigma MI. I is equal to 1 to I is equal to n. This is the way you write. Take the derivative of this, you will get VCM, right? And take the derivative of VCM, you will get ACM. So if you are given a system, please don't start applying, force. So you say acceleration of this is actually F by M2. So F2 is equal to F and all are F. Okay. Acceleration of this particular mass is not F by M. We have to see the system, and then on the system, what is the external force acting? We apply Newton's second law in a specific manner when it comes to a system. We don't apply it to like we draw a free body diagram, take it separate, take it separate. We are now referring to center of mass experiencing acceleration. And center of mass is made up of multiple masses. You can't ignore the masses, right? You do get a strong feeling that, okay, let's write it as F upon M3 and finish, right? No, we are not calculating the mass of the acceleration of the mass m3. Rather, what is our aim? We are finding the acceleration of center of mass. So center of mass of a system is a different concept than the acceleration of an individual mass. So the key word for you is ACM, not A. I hope this has made sense to you. You may get similar questions in your examination. Okay, so don't forget to subscribe to this channel because you will get excellent quality concepts in this channel. Thank you very much.